evening, everyone. So we are actually right now talking about the lecture 4, big data concepts, mostly on representation this time, namely identification, de-identification, and re-identification, three steps, and ontology and semantics. Previously, these actually two different lectures, but I actually try to combine them into one. So you'll find that this round is actually a bit lengthy, but eventually the concept is actually quite straightforward to catch if you are able to uh, make the relationship between these slides. Okay? So yeah, first part of course is the identification, de-identification, and re-identification. So it actually starts with features of an identifier systems and then object identifier. And when you are designing an object identifier, there are actually situations where it's really bad identifier methods over here. So embedding information in identifier is actually not recommended. Okay, we have actually can give you some example for example, your ID, your metric, right now your metric ID somehow is actually sort of updated, so that's why much less information inside. But previously, if you're using your old ID, we can roughly guess where are you studying in your faculty within University Malaya from the ID and also which year that you actually registered. So at this point, I mean, of course, the metric ID, I mean, this embedded information in metric ID is not that crucial, but as examples later on. Okay, why we actually deduce that embedding information in an identifier is actually not recommended this round. And then there are actually one-way hashes over here for you to hide the information that is actually from your particular your ordinary identifier. You can actually transform it using one-way hashes, but still a way for you to identify your data. Okay. Of course, this one-way hashes will be helping you to do a de-identification process. You are able to remove personal identifiable information such as in short is PPI through this particular process. And then lastly, it will be re-identification after your data is actually de-identified. Okay, but under what kind of circumstances you should actually re-identify the whole concept over here. I mean, why you want to get back the original ID of that particular data rows, okay, or data columns. All right. So over here, data identification is certainly the most underappreciated and least understood big data issues, of course, because why we say so is because we most of the time it's like thinking how we are supposed to design the database or how to store the data efficiently and so on, but we pay quite little attention on the identifier itself. Usually we just assign a column of numbers, okay, a column of numbers, and then we just plus one, and plus one, that's it, okay. But when you are actually going into this kind of ways, okay, to actually so-called just plus one and plus one and plus one, your data identification over here is actually quite raw, as in you don't really able to utilize this particular information later on for your data merging, potential data merging with other big data solutions. So let's see how it goes later on when we are discussing. So measurements, annotation, properties, and class of information have no informational meaning unless they are attached to an identifier that distinguish one data objects from all other data objects. So over here is trying to tell you that it links together all the information, okay, that has been or will be associated to the identifier object. So every single identifier over here is supposed to be connected to each other, okay. It's actually a bit similar to your primary key and foreign key if you studied database before. Okay, here are some further explanation. You can take a look if you are interested. And properties include identify information including uniqueness, exclusivity, completeness, authenticity, harmonization, where further explanation is over here. Okay, the quality of your being is one in its kind, and the practice of excluding for or not admitting other things. So all these are a bit more details, okay, a bit more details in terms of that particular identifier, okay? I mean the properties of that particular identifier, but we will have a more in-depth explanation later on for a few slides later on. But this one is just giving you some example. So once data object has been properly identified, this is what I actually explained to you just now, they can be de-identified and also under some circumstances re-identified. And what are the reasons behind is one, when you want to de-identify because of confidentiality, privacy, and intellectual properties. Okay, you want to basically protect the data from leaking or protect your data from being exposed due to privacy concerns and so on. But when you are actually needed to re-identify, basically it's because you want to do error detection, error correction, or data validations where you find out that it's either you want to validate whether the data that you're capturing is actually correct. That's why you want to re-identify back the original data. Or you actually find some benefits from the data that you actually have and you want to find out where the data is coming from so that it's beneficial to that particular data provider or contributor. Okay, but let's move on and see. So, good information system is an identification system where provide a way of naming data objects over here, so that they can be retrieved by their name. Okay, so this one is using, we so-called in your other classes, maybe you call it as unique identifier, okay? Or again, primary key. It's just that over here we are talking about identification systems and so on. And then eventually this so-called identification system is helping you to distinguish each object from every other object. So every single object must have one specific identifier over here. Okay, if data managers over here properly identify the data, they will be producing a collection of data objects with more informational value than many existing big data resources. What we are talking about here is we try not to have personal identifiable information within your identification system, but some general concepts or general grouping criteria you can actually put it inside, so that in the end of the day it's going to be helping you in analyzing your data. Okay, so the way for you to design your identification system will be quite crucial at this point. So over here, an object identifier is definitely an alphanumeric string. Of course, it can be just alphabet or numeric, but in general, alphanumeric is acceptable. And then for many big data resources over here, the objects of the greatest concern of data managers are human beings. Most of the time, the systems that you're creating are all for human beings. Okay, like for example, hospital systems. Main thing is patients, doctors, nurses, and so on. And library systems. Okay, patrons and also librarians is also one of the important elements inside your system as well. So most of the time, the big data resources or systems that we are building, the main people we are the human beings within the particular system that is actually involved in that particular systems. Okay, so so basically over here is telling you the data resources are to store and retrieve information of individual humans, and the data manager preoccupation with human identifier relates with the paramount importance of establishing human identity with absolute certainty. So this one is trying to tell you data manager over here is important to make sure, that the identity that you're establishing within that particular system is actually traceable, somehow traceable, easily traceable on the identity itself. Okay, that's why your bank account numbers, is actually unique, right? But are you able to trace your bank account numbers to that particular owner itself just by using that particular set of number? Technically, you won't be. Okay, so that's the job of the data managers. How he or she are able to design a set of identifiers so that that particular identity is actually so-called protected from that particular owner, right? And also with absolute certainty, you want to make sure that the identifier that you are creating is actually really correct, really assigned to that particular object that you are actually designed to, okay? So one of the most important tasks for data manager is the creation of dependable identifier system. So the properties of a good identifier systems are the following, including completeness, uniqueness, exclusivity, authenticity, aggregation, permanence, and reconciliation, immutability, security, documentation, and quality assurance. So this one is actually, you see that they are all having some explanation over here. For example, completeness. Every unique object in the big data resources must be assigned to an identifier. Every object must have an identifier. Every object over here must have an identifier. And uniqueness. The identifier is a unique sequence. You don't have a repeated sequence over here. Each exclusivity. Each identifier is assigned to a unique object and to no other object. One identifier to one object, okay? And one object is also assigned as one identifier, one-to-one relationship. One-to-one relationship, you don't really have one-to-many from any point of time. So, and then authenticity, you want to make sure that the data is actually verifiable by the objects that they're intended to be. So that's the reason why you have an authentication process whenever you are actually going to the bank, you are trying to do some withdrawal, or when you are doing some online transactions or online banking transactions where the operator will actually ask you some verification information. Okay, so there's a way for you to authenticate, okay, your identifier to the objects that are intended to be. There are a way to to make sure that these two things are connected. All right. Okay. Aggregation. The big data resources must have a mechanism to aggregate all the data that's properly associated with the identifier. So, your identifier, you have a lot of follow-up information at the back of, and maybe different columns or different pointers and so on. So, are you able to actually aggregate them together into one whole set of data? Okay, and then permanence. It's supposed to be permanent for you to, for the identifiers that you are creating, okay, maybe, the 30 years ago, you have created this identifier. After 30 years, you suppose the identifier is still somehow correct or valid, okay, unless, of course, there's always an unless, you are revising the whole system. When you're revising the whole system, maybe for maybe you know that for your parents, they are actually having old identification cards, for our ID, okay, or for national ID. There is actually an old version where it's only, I think, 7 digits, okay? But right now, every one of us are having a new set of IC, identification card, where we have 12 digits of numbers. And also our parents are getting the new IC numbers as well, right? So in that case, you're migrating from one system to another system, and then you are revising the whole identification systems over here. But if you notice some of the government systems, they still accept both old NRC and also new IC for you to key in and also retrieve back the data within your systems. Okay, so although the old IC is already so-called obsolete, it's still acceptable in government sectors because it's actually one of the way as well to identify yourself. That's why permanence comes in. Of course, the example over here is different. It's talking about hospital system, but in the end, it's almost the same over here. Then reconciliation, there should be a mechanism whereby the data associated with a unique identifier object can be merged with the data held with another resources for the same unique object. So it's actually trying to tell that if you have a similar big data resources like hospital A, hospital B, and hospital C, similar entities or similar objects within that particular big data resources supposed to be able to merge together. So in that case, right, this also suggests that you're supposed to have an identification system that is similar for hospital A and B and C. But is it really true? If it's true, then it's good, easily mergeable. But if it's not true, what are the process process that you need to do so that the merging is actually possible? So this is what reconciliation means. That immutability, again, this one is a bit similar to veracity, where you want to, permanent, but also, of course, veracity as well, because you want to make sure that the data when you store into a system is actually never change. Never change as in, you don't really get corrupted or yeah, basically corrupted. So how are you able to avoid this data corruption? Okay, it maybe it's even easier when we are doing in the old days where everything is actually in paper. So it's actually hard copy in paper writing. So it's actually very hard for you to change it. But if everything is digitized within a digital computer system, how are you able to prevent that there is actually data corruptions or hackers that is actually hacking a system and changing the data, which is quite crucial to that particular objects or so-called human beings or users over here. So how are we able to ensure immutability? Then security. The identifier system is vulnerable to malicious attack. So how are we able to make sure that over here, the identifiers over here, once you are changing the identifiers, okay, your system somehow is actually irreversibly corrupted. So in that case, if you somehow try to change the identifiers, maybe in the end of the day, your whole system is actually collapsed. Somehow technically it's actually good as in you are able to protect the data inside from malicious access. Okay, malicious attack and also misuse. Okay, you prevent the misuse. But the bad thing about it is, of course, your whole big data resources involved, and it depends on do you have backups to actually restore the whole thing or not. Okay, and then documentation and quality assurance. The system should be in place to find and correct errors in the patient's identifier system. So this one is about documentation, where you need to make sure that your data is able to be retrieved in a well documented manner and also reviewed, possibly being reviewed. Okay? So for computer scientists, so a data object here is a holder of data values, become the descriptor of data. That's why at the beginning of the class I'm talking about representation. You are trying to give a set of alphanumeric strings to represent the data rows for every single to the data for every single row that you actually have. Okay, based on the properties of the holder, for example, the class of the object to which the instance belongs. Okay, so uniqueness is achieved over here when the data object is permanently bound to its own identifier sequence. And it's supposed to have three properties over here. It can be distinguished from other unique objects, but basically it's like one-to-one relationship. Your unique object, okay, can be distinguished by other your unique object can be distinguished by other unique objects by using the identifier sequences over here. And then a unique object cannot be distinguished from itself. So basically, you must, because a unique object compared to a unique object itself, of course, it's the same. And lastly, uniqueness may apply to collection of objects. For example, a class of instances can be unique, right? So over here, it's actually giving you an example of a registry number of suffix sequence appended locally. So life science identifiers is similar to our the identification card that I'm giving as an example, but over here is actually a typical example of registry identifier. Every RSID is composed with the following 5 parts, which is now identifier, recipient's names, and so on. And this is the whole thing. Okay, comparing to this. So you notice that whenever you are actually getting different information using this, where you actually have different separators over here, it's actually giving you more and more info where you actually can interpret in this way. Okay, so this identifier actually giving you certain kind of meaning inside, right? So in some cases, the registry does not provide a full identifier. So the registry may provide a general identifier sequence to apply to every data object in the resources. So maybe in that case, you just want to use, you only give up until here. Then you get all the entry falls in this particular category. So maybe you got GenBank T48601, 1, and also 2 and 3 and 4 and 5 and so on. Okay, or 5th version. Okay. So an identifier object over here is a hierarchy of identifier prefixes. So successive identifier or prefix identify descending order of the hierarchy. You notice that every single level you can treat it somehow like a class or a grouping. Okay, so that it basically helps you to know your particular identifier is actually somehow belongs to a certain kind of categories when you are actually using this kind of identification system. So another example is actually hospital use the OID system to identify image part of the DICOM. So this one is actually talking about the scan. Oh, this one is a scanner. This one is just trying to tell you how they actually identify the image. And there's a prefix consisting of a permanent registered code for the institution, and the suffix consisting of a number generated for an image and is created. So over here, the example is, okay, the first image created is the computer tomography scanner. Then it's assigned to identifier consisting to the OID, followed by a separator as hyphen, followed by 1. I think there are further explanation over here. Yeah. So in a worst case scenario, the different instrument may assign a consecutive number to images independently to one another. So this means that, okay, imagine, yeah, right now it's actually giving you a situation. Over here and here is just trying to tell, at the beginning, it's just trying to tell you a process. How are you actually able to build a so-called OID system, object identifier over here. OID is object identifier system for identifying the images that is actually scanned using a scanner. Okay, so in here, the CT scanner in room A may be creating the same identifier as a CT scanner in room B for images in different patients. Why is this happening? Okay, because you are only creating your data identifiers using the information of scanner as well as the counting of numbers of images. If you still recall, over here, it's actually here. Followed by a separator, so a hyphen, and then followed by 1. Okay, so if it's second image, then it's followed by 2. Right. So in that case, there's a possibility that when you are actually having room A, okay, room A have one scanner, room B have one scanner, okay, and then every day they maybe room A have generated 10 images, room B have generated another 20 images. So the first 10 images from room B, the identity is actually duplicating with the 10 images in room A. So that's the problem if your object identifier is actually not designed carefully. Of course, over here the easy solution is you add the room A as part of your identifier as well. Right. So this much how you actually can design your object identifiers. And this one, the image service is assigned to another department in the institution when department merge, when other institution merge. So the old records will be assigned to the same prefix and contents replicate. So this one is actually a CT scanner example using room A, but this one is almost a similar example. It's just that right now the image services is moving to another department or institution. But again, if your original identifier doesn't have the department information, okay, so imagine both institutions, okay, you have a CT scanner, you have room A and room B for both institutions. So in that case, when you join together, definitely there will be a clash as well because you have your department A and department B from different institutions. But your naming convention, okay, or so-called identifier system over here follow the same steps, where you won't be able to differentiate later on. Actually, this particular image using this identification system is actually from department A or department B. Okay, so these are the things that you need to consider when you are actually doing the merging. Okay, before you are doing the merging, what are the things you need to do in extra so that your identifier is actually still valid later on after you merge it. Really bad identifier methods basically tells you a situation where names are very, very poor identifiers. Okay, because why? Aside an obvious fact that they are not unique. Okay, like for example, Smith, John, Garcia. So all these are actually very, very common names. A single name can have many, many different representations. Why? Okay, because sometimes, okay, I am giving you a lot of examples over here, so you can actually take a look if you are actually interested. Okay, there's a lot. Because Imagine if you are like maybe your parents or even your when you check with your parents or your grandparents and so on, when they are going into their first registration on their identification, I mean, when we are actually having we are actually Merdeka, okay? We are actually independence. We are our nation is actually going into independence. We are actually facing troubles because of maybe they have some language issues and so on. The name, okay, they're actually pronouncing when they're actually going for the identification registration is actually they pronounce it differently. It's where it maybe in the end of the day, if they are actually brothers and sisters, but the surname that they actually pronounce is a bit different, then in the end of the day, their surname is actually in the end different somehow. Uh, I think it's actually quite common in a Chinese community over here, if you're aware of. But it's actually also quite similar to other kind of community as well, where surnames is actually quite common. And I believe if you go into, I mean, throughout your study, or for during your first year, or sorry, your first year, second year, or maybe primary, secondary school, there must be some students, okay, that your name and your friend's name is actually can be very, very similar. Maybe similar in terms of the last name, or similar in terms of the first name. Or I won't, maybe I don't use the word similar. Exactly the same. Okay, so you both of you can only be differentiated by the last name or by the first name itself. So in that case, right, this becomes a very, very bad identifier. And in and trust me, there are definitely somebody around the world that is actually having an exact same name out there. So in that's the or also the reason almost I think every single country will always have their own identification system, including our country is actually identification card, right? We besides the identification card, we have also our driving license cards. So all these kind of different identification system is helping us to differentiate, okay, these kind of issues on name itself, because name is over here is really a bad identifiers. So please take a look on the example over here. Second thing is, most identifier are not purely random numbers, which I mean, even our example just now is actually showing that they have certain kind of sequence, and given that particular certain kind of sequence is giving you certain kind of meaning. Okay, but okay, we are hoping that okay, the identification system that we are using don't embed the personal identifiable information inside, which somehow in our identification card in Malaysia is actually a little bit bad about us because why? In our identification card, we can know that when is our birth date and also where you were born, okay, and also the last digit of it, then you actually know that it's actually a male or female. So all this information, and it's actually personal identifying information, is actually embedded within your identification card. Of course, you still have maybe you still have another three numbers that is actually quite unique. Okay, or three or four numbers because the last four numbers can be random. It's just that I mean the last four numbers, the last number itself is actually still be controlled by odd or even numbers. But over here, the if it's really an identification card over here, this particular embedded information can really sometimes give you certain kind of unnecessary data leakage. Okay, if somebody wants to know that when do you actually have a birthday, they can just simply check on your IC, which sometimes IC is not that hard to access. Okay, at some of the points. So I mean, it really is a bad idea for you to embed personal identifiable information inside the identifier that you actually have. But okay, unfortunately, this is what we have right now. Maybe I'm not sure about other countries, but maybe social security numbers or so-called our identification number really having this kind of embedding information for a specific purpose, which maybe I don't know, but maybe it's useful, okay, for that particular government system. Okay, so why we don't suggest this to happen is because considering this scenario, okay, so take a look at this scenario for a while. I'm gonna read it out. So you know that a prominent member of the president's staff have visited Washington D.C. on February 15, 2005 for the purpose of having a liver biopsy. Okay, okay. So you know that you have a specific date. Okay, and then you have also known the liver biopsy, and you really want to know the results of the lab biopsy, whatever reason it is behind. So you go to a website that lists the de-identified pathology records for the hospital for the years of 2000 and 2010. It's actually de-identified. Okay, so when this particular record is de-identified, we are assuming that okay, the patient's information is actually removed. So you not supposed to be able to know the identity of that particular patient. Okay. Although no personal identifiers are included in these public records, the individual records are sorted by accession numbers. Okay, sorted by accession numbers here. So using the aforementioned strategy, so you collect all the surgical biopsies performed on or about February 2005. Why he's actually choosing this one is because you know that the president staff is actually going for a liver biopsy on this particular date. So you try to get this one. And of these biopsies, only 3 are liver biopsies. Okay. And then of these 3 biopsies, only 1 that was performed on a person whose gender and age match the president's staff member. So you notice that there are actually a number of personal identifiable information, gender and age, which actually, in general, gender and age doesn't really give you any personal identifying information, but somebody with some specific purposes behind, okay? If they somehow know certain kind of information about this particular president's staff, in terms of the date and also the purpose where he's having a liver biopsy, and he knows about the gender and age, and try to do a cross match with the identified pathology records over here, then the report on the diagnosis, you'll be able to match it with this particular president staff. Okay, even though the data is actually de-identified. So right now, you know that it's actually very crucial for you to remove the personal identifiable information as much as possible. So actually gender and age is not so recommended as well as for you to actually release it as a public data. But somehow in some cases gender and age is still released. Okay, because still it's actually a number of arguments over here why if we stand alone, then it really is not able to help you in finding the outcome. But this particular person having no extra information on February 50 and also liver biopsy, then he's able to get this particular private information about the biopsy, right? So over here, it's trying to tell you that the alphanumeric character string composing identifier should not expose the patient's identity over here. Of course, over here, we actually doesn't really have the example. Throughout this scenario, it doesn't really mention about the identifier, how it's actually designed. But maybe, okay, I believe the identifier that they are using are able to extract gender and age from there. Okay, similar to our identification card number. Okay, because when you have date of born and also the last digit of the IC, then you know the gender and age. Right, you can basically generate the gender and age from there. So this is how we are justifying personal identifier information is really not recommended. Okay, then one-way hashes. Okay, one-way hashes is actually for a way for you to transfer a string into another string in such a way that the original string cannot be calculated by operations on the hash value. So in that case, it's somehow we are using the word irreversible. You won't be able to recalculate this particular string back to your original name. Okay. Why we are using this example? Because you imagine Jules Berman is actually also the author of this particular content. So Jules J. Berman, okay, a slight changes on the string actually resulting in a very huge changes on the MD5 string or hash string. So in that case, it's actually a good way. It's actually a good way for you to de-identify your information. Okay. How are you able to, like for example, change your identity card with your personal identifier information using one-way hashes? Okay. So one-way hashes can substitute the identifier the individual data record. This permit the data resource to accumulate data over time to a specific record, even the record is de-identified. Okay. So, okay. So why we are actually using one-way hashes? Because it's actually so-called a standard way. A standard way where a data manager actually can use it to every time, sorry, not the data manager, data provider, okay, can use it many times, anytime to actually, process your identifiers so that in the end of the day, every time when you're sending your data to data managers by the data provider, the identifier that you're using is always so-called de-identified in this round. And also, it's actually always the same based on your original, because it's generated based on your original identifier. So in that case, you will be able to accumulate your data over time to a specific record, even though the record is de-identified. Okay, but of course, you need to know what kind of parameters they're using on the hashes. Of course, one-way hashes is also having certain kind of issues where if you are having a complete listing of all the original identifiers, then if you also know that the hashes, the parameters of the hashes that they are using, so in the end of the day, you just need to do a hash on the original set of identifiers, and then once you get the result, you just make a lookup table. Then in that case, it's basically you are just creating a lookup table and again cross-check with the data that is actually available by the data manager. Then you'll be able to do what we call as a dictionary attack over here. You are able to somehow match the record, which is supposed to be de-identified. Okay, so that's why the original identifier sequence must be kept secret. Okay, so these one-way hashes that we discussed basically brings the concept from identification to de-identification here. So in general, de-identification is a process of stripping the information from data records that might link the record to the public name of the record subject. So this is actually what the one-way hashes that we are talking about doing. Okay, so that's why the one-way hashes is discussed a bit earlier, so that it can bridge the connection between identification and de-identification. Okay, so over here there's examples where you can actually maybe combining names, address, and date of birth, and then social security number, and then you generate one so-called unique identifier from there. Okay. And the de-identification involves removing information of the data objects that can reveal something about the public domain of the data object. Okay. For example, the things that we have discussed just now is actually the gender, age, place and live, when they're actually going for certain kind of action, like for example, the liver biopsy that we're talking about. So all these can be the information for you to know or connect to the original publicly known name. Okay, and this kind of information is often referred to as identifying information or name linking information. Okay, so it may seem counterintuitive, but there's a very little difference between identifier and the de-identifier. Under certain conditions, two concepts are equivalent. Why? Because identifier is actually matching with one object. Okay, identifier is actually matching with one object. De-identifier is also matching with the same object. It's just that right now the identifier itself doesn't have the personal identifier information for that particular object anymore. And how are you able to change from identifier to de-identifier? One of the example is one-way hashes. Okay, so it's something like a triangle over here. Okay, so this one is actually trying to tell you about what we understand about identification, de-identification system can work. Okay, so you have a data on unique object. Joe's Ferguson bank account contains $100. This is actually something you want to hide. Okay, assign a unique identifier. Joe's Ferguson bank account is actually 7540033 and so on. Substitute the name with an assigned unique identifier. This one, this account contains $100. Consistently use the identifier with data, which is this one. And do not let anyone know that the Joe Ferguson knows account of this. So in the end of the day, nobody will know that Joe Ferguson is having 100 ringgit in the bank account. You are changing from the identifier to the identifier over here. And the identifier over here is actually your own name. And the identifier over here is actually your bank account numbers. Okay. The main thing over here is if you want to hide this original method is you need to make sure no one knows Joe Ferguson linked with this particular or owns this particular account number. So in that case, then you will not have this particular information leak. So the dual use of the identifier and de-identifier is a tried and true technique. Okay, so just now the example over here. Okay, tried and true. So the suspect accounts are essentially unique numbers assigned to a person. So you access the bank account by producing the identifier number, and the identifier number does not provide the information about the identity of the bank account holder. Okay, so this is what we understand as identifier. Okay, and de-identifier over here. Then the purpose of the identifier is to tell you that whenever the identifier is encountered, it refers to the same unique object. Whether two different identifiers are encountered, they refer to different objects. The identifier over here by itself contains no information that links the data object to its public name. The main thing over here is like this. Okay. But okay, you might question that just now we are saying that it's actually only one identifier. We only have one identifier to one object, but right now it looks like you're actually having two identifiers for one object. You need to know that from the system point of view, only identifier is working or de-identifier is working. It's either one. You only choose one to work. Okay. When you're de-identifying your data rows, okay, you are making a transformation from identifiers to de-identifiers. So in that case, right, you are transforming the usage from one to another one. So at one same time, it's still only one set of identifiers. It's just that it's either this one or this one. Okay. So at this point, you might be asking yourself one question. So what gives the data manager the right to distribute parts of the confidential record even if it actually happens to be de-identified? This is what a data manager needs to justify where is the confidential record that you actually distribute for research purposes, development purposes, or even any purposes, maybe data collection for certain kind of analytics and so on. How are you able to ensure that the information that you are distributing really de-identified properly over here? How are you able to make sure that the de-identification over here render the data harmless to the data provider, okay, about a person or a data object, which is about nothing in particular, right? So that one is until de-identification over here. Then last part is actually re-identification. So for scientists, de-identification serves two purposes. Okay, you want to protect the confidentiality and you want to remove the information that might bias the experiment. There are 2 points actually. One point is the what we have actually discussed just now. You want to make sure the confidentiality, privacy, you don't leak your own data. The next thing is you can actually have certain kind of bias if you know that particular person, okay, which is quite common, okay, and then that's the reason why you want to remove it when you are actually doing the research work, okay. So because the confidentiality and privacy concerns, so this one is the same, we are actually entering re-identification. Okay. So scientific integrity does not always accommodate irreversible de-identification. Why we don't want to we don't want to make sure irreversible de-identification specifically for scientific integrity. Okay, because there's a situation where your experimental sample are mixed up, sample thought to come from a certain individual tissue or may come from another source. Eventually, it tells you that when you are doing your scientific research, you need to make sure that your data veracity or so-called data, the accuracy of the data is actually the higher the possible. Okay, so in that case, right, for you to make sure that your data, so-called de-identified data right now, is actually having the good integrity, okay, or good source of validation. So in that case, you will need to have a reversible de-identification, and you need to have so again another data manager responsible in reversing this process, okay, and is actually responsible in judging the reason from the scientist why you want to do this particular so-called re-identification process. What is your justification? And when the justification is all right, then the data manager will actually perform this re-identification process for this particular scientist because they want to validate the experimental samples or data that they are collecting, whether they are actually follow certain kind of rules or scientific rules and so on. Or they want to collect more data, that's why they want to go identify the original data provider so that the data managers are able to request new data from the data provider. So this is how it works. So sometimes major findings in science need to be retracted when a sample mix-up has been shown to occur. So when samples are submitted without mix-up, that is sometimes called sometimes collected improperly. So this one is giving you some examples. What kind of scientific research that can go wrong, and how the reason you are actually needed to find out. Retract the publications or retract the publication because of the data that you're using is not validatable, or in the other day it's actually wrong. Okay, it's actually wrong at one point. So this reversible de-identification process, or what we call as re-identification, at one point is important. Okay, and to preserve scientific integrity, so it's sometimes necessary to discover the identity of de-identified records. Okay, so in some cases, de-identification stops the data analyst from helping individuals whose confidentiality is actually protected. Okay, you need to imagine a situation where, when you are actually in a medical scenario, okay, maybe a patient provided you a set of data where you are actually doing research using this set of data, and somehow you find a cure for this particular patient. But right now, your data is actually de-identified. There's no way for you to locate or identify the original patient that's giving you the data. But you know that the cure that you have discovered, you'll be able to save the original patients from here. So in that case, the re-identification process over here will be important because you can save the patient's life. So do you think that at this point the confidentiality is important? No, because life is more important at one point. Okay, but of course this one is again subject to the agreement on the particular patients. Okay. And if the patient is not really doesn't really agree to use the chair, then of course the re-identification process is not gonna work. Okay. So concluding remarks over here. So you are actually having a list of points that is actually a summation. Okay. This concluding remarks, basically we are actually doing some not to say summation. We are just trying to over here we're just trying to repeat. Okay. Repeat in general what we are actually talking from identification, de-identification, in the end re-identification. So this one part you can actually read yourself. Okay. Because it's gonna be a bit repeating from your previous process. Okay. Okay. Right now we move on to ontology and semantics. But I will actually create another video for this one. So because I want to upload this part first, and then you have the part two, then we have the part three for the lab later on. Okay. So see you later.